Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 6.5, day 2, entitled The Law of Sines. And in the previous section of notes, we reviewed the basics of the law of sines, and we started talking about the ambiguous case. So we're going to talk about the other two parts of the ambiguous case today. Now, remember, there's three possibilities when you're dealing with ambiguous case. You could get no triangle, one triangle, or two triangles. And in the previous section of notes, the 6.5 day 1, we talked about when you get one triangle. So today we're going to talk about what happens when you get two triangles or no triangle. Now, this note in red here is basically what you have to remember, okay? If we're taking the sine of some angle, and that angle is less than 1, this is where you have to check to see if you have two triangles. So once you do the sine or the second sine of that value that's less than 1 in your calculator, you're going to get an angle measurement, and then you have to basically subtract it from 180. Okay? Once you do that, then you'll be able to have your two cases, and you can check and see if both of them are possibilities or not. So it's better to work through it in an example. Okay? So remember, this is when you are going to be given information that is a side-side angle. Okay, and up here in the example it says side-side angle. And if you have this backwards, it's instead of SSA, it's, the other letters backwards. So that's how you remember that this is a pain in the butt because of what this spells backwards. Okay, so just keep that in mind when you're dealing with a side-side angle scenario for your information. This is where you're going to have a possibility of having one or two or no solutions. Okay, so again, they want us to solve the triangle, so that means we have to find all the stuff that's missing. And they give us angle A is 43.1, and they give us side A is 186.2, and they give us side B. So you have an angle and a side and a side. Okay. Now the picture that they've drawn here kind of sets up the images for the two cases. So if you look at this little sliver in here, that could be one possible triangle. Or if you look at the whole big triangle where A is kind of swung out so that it's over here, that's going to be your other possible solution. Okay? But remember, when we're dealing with these problems, we want to start with the law of sines and the proportion for the law of sines. So let's see if we have an angle and a side that's across from it. Okay, they gave us angle A and they gave us side A. So we definitely have, for our first step here, we have the sine of 43.1 over 186.2. So that's the law of sines there. We're doing sine of A over A equals. Now, the next thing we're going to try and find is going to have to be angle B, because the only other piece of information I'm given is side B. So I'll have to do sine of B over 248.6. Okay, so these are big numbers. It's just kind of irritating that they're big numbers and they're decimals. Doesn't matter, we're using our calculators anyway. Okay, so now when I cross multiply and divide, I'm going to be solving for angle B. Now I'm going to do the cross multiplying and the dividing in one step here. So we'll have sine B equals, now I would take the 248.6 times the sine of 43.1, and then I would have to divide it by the 186.2. Okay? When you type this into your calculator, again, do the 248.6 times the sine of 43.1, get an answer, then divide by the 186.2. If you type it into your calculator in one big step, one big string, make sure you put the numerator and the denominator in parentheses. Otherwise, you might get the wrong answer. But you should get 0.9123. Again, we want our calculator to be in degree mode. Oops. Okay. Now, on the previous slide, we said that we have to watch out for when the sign value is less than 1. Okay? Here we have the sign of b giving us a value that is less than 1. 0.9123 is less than 1. So when we do this on our calculator, you're going to do the inverse sine, or sine to the negative 1, of 0.9123, and that will get you the measurement for angle B. And it will get you 65.8. Okay? But now remember, there's two possibilities here for our solutions. Okay? So it could be a 65.8, or it could be 180 minus 65.8. So my other possibility for B would be 114.2 degrees. Okay? So how we check these, how we rule these out, is we take a look at these measurements and the angle measurement that I was already given. So I'm going to do this in a different color here. If I take 65.8 and I add the 43.1, that's going to get me 108.9. I still have plenty of room there to go up to 180 to form a triangle. So this is a possibility for an angle measurement. And if I take the 114.2 plus the 43.1 that I was given for angle A, that gets me 157.3. Still plenty of room to add in more so that I go all the way up to 180 for my third angle. So here, both of these are possible solutions for angle B. So now this tells me that I'm going to have two triangles. So I have to finish this problem twice. I have to go through the work if angle B is 65.8, and then I have to go through the work for if angle B is 114.2. Okay, so I was given angle A and side A. I found angle B and I have side B. So really the only other two things that I need are angle C and side C. So I'm going to go to the next slide where I have some more room here. And I'm going to do my next phase of this problem, assuming that the measure of angle B is the 65.8. Okay? So next thing I would find then would be the measure of angle C, and that would be 180 minus whatever the 43.1 and the 65.8 are. I think we found that before. That was the 108.9. So that tells me that the measure of angle C is going to be 71.1 degrees. So that's one of my options for angle C. Now if angle C is that, now I can find side C. So I can do sine of the 71.1 over C. And then the other information that I was given was the angle A and the side A. So that's what I want to set my proportion equal to here. And again, now we're going back to just good old law of sines using our proportion. And then I'll cross multiply and divide. So 186.2 times the sine of 71.1 divided by the sine of 43.1. And again, I'm doing the cross multiplying and the dividing in one step. Hopefully you're okay with what I'm doing there. Okay, I'm taking out that middle step where I would multiply this out and set it equal to this and then divide. So I'm just taking out that middle step there. Okay, I talked about that in the previous section of notes. So when you put this into your calculator, you should get 257.82 for your side length. Okay, so that's one option. My other option then would be if the measure for angle B is 114.2. So then I would have to find the measure of angle C, but I would take 180 minus whatever the 43.1 plus 114.2 is. And we added that up before. We got that to be 157.3. So 180 minus the 157.3, that's going to be 22.7 degrees. So that's my other option for my second triangle. That would be the measurement of angle C in my second triangle. And then I have to do the proportion again for the law of sines. So again, I knew, I know now C is 22.7. And then I had the measurements for A. That's what I was given when I started the problem, so I want to use that given information. Okay. So really the only thing that changes from this previous setup is the number that I'm putting in for the sine, that angle. Okay. Otherwise it looks exactly the same. And even when I cross multiply and divide, the only number that's going to change is that 22.7. So I have the 186.2, whoops, 0.2. Erase that. Times the sine of 22.7. I'm going to divide by the sine of 43.1. And now this time my measurement for the side C, when you type this into your calculator and get your answer, will be 105.16. Okay, so this is my options then. This would be my first triangle. These are the possibilities for my first triangle. This would be the possibilities for my second triangle. So everything else would be the same. Angle A and side A and angle or side B, those would be the same as what I was given. So these three given pieces of information would all be the same. The only thing that would change then would be the measure of angle C. If it's a bigger angle, so it's a more narrow triangle, or if it's a smaller angle, so that side is kind of kicked out a little bit. Okay. And then the corresponding side length. So these are time consuming. These take a little bit of work because you have to basically solve the problem twice. But again, notice that it's the same work. The only thing that's changing is one little number here. So the only thing that's changing is the 71.1 and the 22.7. So if you're really good with your calculator and you know how to just do the second entry, you can go back and you can just edit those numbers and then hit enter again instead of having to type everything into your calculator twice. So it can save you a little bit of time that way. Okay, last example then is to talk about what happens when you have no solution. Now these are meant to be pretty fast problems, okay? You're still going to be given information about an angle and a side. So here we have angle A, and side B. Okay, so you have a side angle. And if you start to you draw your triangle, you start to work through the problem, you label everything, you say, okay, so now if I'm going to use the law of sines to solve this triangle, I've got my angle A and my side A across from each other. So you would do the sine of 42 over 70, and then you would set that equal to, you'd have to find angle B next, so you'd set that equal to sine of B over 122. Now I know for most of these examples it seems like we've been finding angle B. You won't always be finding angle B. Sometimes you might find angle C, or sometimes you might find angle A. It just depends on the information that's given to you. Okay? So now if I cross multiply and divide, let's see, sine B would be equal to 122 times the sine of 42 all over 70. So that decimal then is going to be 1.16. Now if you type this into your calculator, it's going to give you an issue. Okay, it's not going to be able to do it because this value is greater than 1. Okay, so if you tried to do the sine to the -1 of 1.16, you're going to have an issue. That's because that value isn't between -1 and 1. Our domain values for our sine functions have to be between -1 and 1. This is greater than 1. So in this case, you have no triangle. Okay, so being able to identify when you're dealing with an ambiguous case really depends on two pieces of information. You have to be given a side and an angle, so that way you know you're going to be dealing with the ambiguous case. And then after you do your first part of the law of sines and you're trying to find this first angle measurement, that value, if it's greater than 1, you have no triangle. If it's less than 1, then you need to check and see if you have 2 triangles or 1 triangle that you're dealing with. So between this day of notes and the 6.5 day 1 notes, you have an example for all 3 of the ambiguous cases. So use your notes and use your book. There's good examples in the book as well. But definitely practice these problems. Again, they're all odds, so you can check your answers in the back of the book. Watch out for rounding issues. Sometimes if you round to tenths or hundredths or thousandths, that can throw off your answer just a little bit from what's in the back of the book. If it's off by a little bit, it's not a huge deal. If it's off by a lot, then go back and double check your work. But if you have questions, come on in and see me before school.